Good morning, students. I welcome you all again for the another session. Today we're going to take one more problem and to find out the support reactions. So the problem is like this: a beam A, B, C, D, E, F, okay, is hinged at A. Okay, so there is a hinged support at A and supported on rollers, that is supported on roller at point E, and carries the load as shown in figure. So there will be load as shown in figure. Determine the reactions at the supports. Okay, we're going to find out the support reactions. So one important observation you can make here is which type of beam it is. Now see, this is a hinged support and this is the roller support. So even after this support, the beam is extended. Okay, can you see this EF? Okay, the portion EF is extended beyond this support. So this beam is called as overhanging beam. Okay, what is this beam? This beam is known as overhanging beam. So even after the support, okay, the beam portion is extended on one side. So it is called as single overhanging beam. Suppose even after the support A, if the beam is extended here, then it is called as double overhanging beam. Okay, now in this case only after support E the beam is extended. Okay, this is called as single overhanging beam. Okay, now as usual, this is hinged support, this is roller support. First we're going to draw the free body diagram. Okay, we're going to draw the free body. So as usual, you can draw the beam AF, A, this is F. Okay, and see the supports. Support is at A, hinged support is at A, means there will be two reactions, that is RAH and RAV, and the roller support is here now, not at the end. Roller support is at point E, so there will be one reaction, that is RE. Okay, then as usual, this is the inclined load. Okay, we can resolve this vertical and horizontal. So vertical component is 20 sine 45. Okay, vertical component is 20 sine 45 and horizontal component of this is 20 cos 45. See, this is 20 cos 45. Then there is a moment or a couple. This is a clockwise moment, that is 20 kilonewton meter. Then this is point load as it is. Okay, and this is the reaction RE, because this is a roller support. There will be one reaction, that is RE. Now see, another important observation is here it is a triangular load. The triangular load is between E and F, and here it is maximum, that is 10 kilonewton, and here it is 0. So one point it is 0 intensity and other it is maximum 10 kilonewton meter. Now how to convert this 10 kilonewton triangular load into point load? How we have got this 7.5? Okay, after converting this triangular load, we have got point load as 7.5 kilonewton. See, this is here. So I have shown here. So first take the area of this triangle. Okay, take the area of triangle. So here I have drawn this sketch, that is a triangular load, same. Okay, the base of this triangle is 1.5 meter. So base of the triangle is 1.5 meter, and this is maximum intensity 10. Okay, now what is the area of triangle? We know half base into height. So half base of the triangle is 1.5 meter. Okay, and height of the triangle is 10. Okay, so half 1.5 into height will be 10. So this, if you calculate, this will going to get 7.5 kilonewton. So this is downward point load. So 7.5 kilonewton load. So here I have put 7.5 kilonewton. And one question you may ask, where this point load will be acting now. Okay, there are two ends, that is one F and another will be E, as we already discussed. So this is called as zero intensity end. Okay, the load exactly here is 0, and at E it is maximum. So when you convert this triangular load into point load, so point load becomes 7.5 kilonewton, and this 7.5 kilonewton will be acting here distance of 7.5 kilonewton from F. So if you want to show from F, okay, from F, so F is called as zero intensity. There is no load here, it is 0. So from 0 intensity, this will be 2/3 of base. Now see, from F, this point load will be 2/3 of base, that is 2 by 3 times of base is 1.5 meter. So 2/3 of 1.5 meter means it is 1 meter. Okay, and from this end, okay, from end E, so it is 1/3 of base. Okay, See here, from point E, the point load will be 1/3 of base, that is 1/3 of 1.5, that is 0.5 meter. So means point load will be, when you convert this triangular load, the point load will be 7.5 kilonewton. This will be acting 2/3 of base from 0 intensity. From here it is 2/3 of 1.5 and from here it is 1/3 of 1.5. So 1/3 of 1.5 means 0.5 meter and from here it is 1 meter. Okay. So this is how you will going to convert the triangular load into point load. Now this is the free body diagram. So two reactions, RAH, RAV, one reaction for the roller, that is RE, and remaining things, this is inclined load. So you have resolved this into horizontal and vertical. Then this moment you will going to show as it is. If it is clockwise, show clockwise. If it is anti-clockwise, show anti-clockwise. Then this is point load and this is triangular load converted into point load. Now you can use, now how many unknowns here? We have to find out RAH, we have to find out RAV, and we have to find out reaction RE. Means 3 unknowns are there. So how many equations of equilibrium available? Okay, 3 equations, that is summation of M, moment about any one support is 0, summation Fx is equal to 0 and summation Fy is equal to 0. So you can use these 3 equations one by one and you can find out the 3 unknowns. Let us take a moment of all the forces about A. Okay, so now remember one more important thing, as we have already discussed, when you are taking the moment equation, you have to take the moment always at any one support. Now where is the support here? At A now and at E. Okay, so either you can take MA is equal to 0 or ME is equal to 0. Don't take the moment at this point or moment at F. No. So either you have to take moment at any one support. Okay, so now let us take moment about A is equal to 0. Okay, moment about A is equal to 0. Now see, as usual sign convention, clockwise it is positive, anti-clockwise moment it is negative. Now take one by one force. First 20 sine 45 into 1. Now see this, how it is 20 sine 45 into 1. See, first force I have taken this. See this free body diagram. So we are taking moment about A. So these two will be 0. Moment of RAH, moment of RAV, and moment of this 20 cos 45, because all these 3 will be passing here only at A only. There is no perpendicular distance. So moment of this is 0, moment of this is 0, and moment of this force is 0. Now 1, okay, we have to take this moment 1, 2, 3, 4, 5. Okay, so start with this moment of this first force about A. So with reference to A, this is clockwise. Okay, this will going to produce clockwise, means plus. So plus 20 sine 45 into what is the perpendicular distance between A and this load, that is 1 meter. So plus 20 sine 45 into 1. Okay, then this is 0 now. Now see, this is next. See here, this will be clockwise now. Already it is moment. See here, 20 kilonewton meter. This is already moment, or this is already, okay, given moment. Okay, just you have to see whether it is a clockwise or anti-clockwise. Don't multiply again perpendicular distance. No. So it is a moment. It is not only force, it is a moment. Okay, so moment is clockwise, that is 20 kilonewton meter. It is clockwise means it is plus. See here, first one is 20 sine 45 into 1. Second one, moment, it is already moment plus 20 because it is clockwise. Next is plus 30 into 3. So plus 30 into 3. Now this force, this is a 30 kilonewton force. What is the perpendicular distance between this 30 and A? This is 1, 2, 3. So plus 30 into 3. Okay, next RE into 4. This is minus RE into 4. Now see, this is RE now. Now with reference to A, this RE will going to produce anti-clockwise. Okay, this will going to produce anti-clockwise means minus. So minus RE into 4. 1, 2, 3, 4. From here to here, minus RE into 4. So that is minus RE into 4. Next, 7.5 into 4.5. Don't forget to take this force. It is plus 7.5 into 4.5. So 7.5 is the point load. And what is the perpendicular distance between this 7.5 and A? 1, 2, 3, 4. 4 plus 0.5. That is 4.5. With reference to A, this will be clockwise. So it is plus 7.5 into 4. So see here, we are taking moment about A. Moment of this is 0. Moment of this is 0. Moment of this will be 0. So moment of this is plus 20 sine 45 into 1. Then this is plus 20 because already it is a moment. Don't multiply again distance. So just see whether it is a plus or minus. In this case it is clockwise, plus 20. Then what is the moment of this? Plus 30 into 3. Then this minus anticlockwise, minus RE into 4. Then this 7.5 into 4.5. This is clockwise plus. So this is summation MA. Moment about A is equal to 0. This is equal to 0. Now only unknown is RE. If you take RE this side, so you can calculate reaction at E is equal to 39.47 kilonewton. So using one equation, we have calculated reaction RE. Now use another second equation, that is summation Fx is equal to 0. That is summation of all the horizontal forces is equal to 0. Horizontal forces only. See sign convention. This is positive, this direction. If the force is positive, then if the force is acting in this direction, it is negative. So how many forces? Summation Fx, x direction 1. This is plus RAH. See, this is second. So minus 20 cos 45 plus RAH minus 20 cos 45. So that will be the two forces. Okay. So see here, plus RAH minus 20 cos 45. This is summation Fx. This is equal to 0. So only RAH is unknown. RAH is equal to 14.14 kilonewton. Okay. So plus means whatever the direction we have assumed, correct. Here also we have got plus means the direction what we have assumed for the RE is correct. Now one more equation remaining, that is summation Fy. That is summation of all the vertical forces. Now see the sign convention. If the force is acting upward, it is positive. If the force is acting downward, it is negative. Then how many forces will come in Y direction? That is vertical direction. Now see, only vertical forces. 1, 2, 3, 4, 5. Okay. This will not comes because this is horizontal. This will not come because this is horizontal. This will not comes. Okay. Because this is a moment, only forces. So this moment will not come in X also. This moment will not come in Y also. Okay. So vertical forces 1. Now plus RAV as per the sign convention. Plus RAV minus 20 sine 45. Okay. Minus 30 kilonewton. Then minus, plus RE. Then minus 7.5 kilonewton. So this and this RE are positive. So plus RAV plus RE, and then this is minus 20 sine 45 minus 30 minus 7.5 kilonewton. So RE plus RAV minus 20 sine 45 minus 30, then plus RE, then minus 7.5. RE already we have calculated here. So substitute RE value, that is 39.47. Okay, minus this 7.5. This is summation Fy. This is equal to 0. So you can calculate reaction RAV is equal to 12.17 kilonewton. So using three equations, we have found out these three unknowns. So the final reactions you can write down. RAH, we have got plus value 14.14 means horizontal. This is the direction what we have assumed. This is correct. RAV also we have got plus. RAV means it is a vertical. Okay, this is the direction what we have assumed. This is correct. Plus means this direction is correct. Similarly, RE 39.47. This is also plus, means whatever the direction we have assumed, this is correct. So these are the reactions. So at A, RAH, RAV, and at E, roller, only one reaction, that is RE is equal to this value. Okay, so I hope you understood this important problem. The change here is this beam. This beam, as I told, this is called as single overhanging beam. Means even after the support, if the beam is extended, here support is not there. Okay, so only the support is here now. beyond this support the beam is extended one side. This beam is called as single overhanging beam. Okay, single overhanging beam. If this side is also extended, then it is double overhanging beam. So I hope you understood this problem. Okay, so solve once again. If you have any doubt, please ask me or call me. Okay, and we'll come up with some more interesting problems in the next session. So thank you very much for attending this session. Thank you.